Average rate of change notes. This is for Advanced Algebra 2, starting Unit 2. So when we think of average rate of change, it's something that you actually learned in Algebra 1. However, in Algebra 1, you were taught to call it the slope. Okay. The reason why they taught it as slope is because we were looking at linear functions, meaning that the average rate of change was constant. It was one constant value across the entire function. When we talk about average rate of change, we are talking about non-linear functions. Okay, so if we look down here at the formulas, you guys are already familiar with that rise over run. Okay, so we used that when we were using linear functions. And then also, you guys are familiar with this formula, even though it looks a little different, okay? Instead, you guys were taught y2 minus y1 over x2 minus x1, which is the same thing that this is saying, except it's saying f of x2 and f of x1. And remember, we learned in algebra that that's another way of just saying y. So y2 and y1. So if we were to find the average rate of change from a table, we would be asked, okay, what is the average rate of change from this point to this point? We'd be given an interval. Okay, so let's look at the first interval. Let's say that we were given an interval from -1 to 2, meaning we would only be looking at these first 2 points, okay? And I would label this as x1, x2, y1, y2. So when I plug it into my equation, I would have y2, so 48, minus y1, -24, over x2, which is 2, minus -1. Since I have minus a negative here, remember that turns into plus a positive. Okay, so if I were to add this across, I would get 72 over 3. And if you put that in your calculator, you get 24. So the average rate of change from -1 to 2 is 24. Okay. They could also ask for the interval from 4 to 8. Okay, so now we are looking at these 2 points here. Okay, so again, I would label this x1, x2, y1, y2, and I would start plugging into my formula. So I have y2 minus y1, so 192 minus 90, over x2 minus x1, 8 minus 4. Okay, that gives me 102 over 4, and if I put that in my calculator, I get 25.5. So notice that my average rate of change from that second interval, 4 to 8, is greater than the average rate of change from that first interval. If we were dealing with a linear function, no matter which intervals we chose or which points, we would get the same average rate of change. Okay? Since they are different, this tells us that this function is nonlinear. When considering rates of change at any given point, it may be helpful to think about the graph as a roller coaster. If the car you are riding is going up, then the function has a positive rate of change. If you are going down, the function has a negative rate of change. So when you think of the slope of a line, if the slope of the line is going up, you know it's positive. If the slope of the line is going down, then you know it's negative. Average rate of change is used primarily with nonlinear functions, since all linear functions have a constant rate of change, so what we mentioned above. Average rate of change can be defined as the slope of the straight line that connects the endpoints of the interval, over which the average rate of change is measured. So if we look at the example off to the right, notice that our function here is not linear, it's a curve that's going up. And it wants us to find the slope within the interval of A and B. So what they did is they connected A and B into a straight line And we are finding the average rate of change for that function. And we're doing so by using that formula here. So it's the same formula we're using, but instead of x and y, they use a and b. So same thing. Now let's look at another example. Example 2 says the graph below records the number of hours and the distance traveled by a family on a trip. The graph is nonlinear, so the rate of change is not constant. So again, looking at this graph is not a straight line. This graph has a bunch of, it is uneven. It has a bunch of turns in it. We can't just say one solid slope for this whole function. So looking at this problem, it says find the average rate of change from hour 1 to hour 4. So hour 1 to 4 is our interval, starting here at hour 1 and ending here at hour 4. Okay. In order to keep this organized, I'm going to create a T-chart. And on the left, I'm going to put my interval, so my x value, so in this case 1 and 4. And then if I look at the graph, it shows me the corresponding y value. So for 1, it's 40, and for 4, it's 180. So again, labeling this is x1, x2, y1, y2. And if I was to plug it into my formula, y2 minus y1 is 180 minus 40 over x2 minus x1, which is 4 minus 1. This gives me 140 over 3, which is 46.67 if you type it into the calculator. Now it wants to find the average rate of change from hour 1 to hour 10. Okay, so here's hour 1 and hour 10. So hour 1 is staying the same, but now we're looking all the way here to hour 10. Okay, so in order to do that, first we're going to create our T-chart, and I'm going to put my interval, so 1 to 10, and then 1 we know is 40, and then 10, if we look at the graph, that's 390. Okay, so then plugging into my formula, I have 390 minus 40 over 10 minus 1, and that gives me 350 over 9. Which gives me 38.89. Okay, again, notice on each of these intervals, I got a different average rate of change. Okay, so on that shorter interval from 1 to 4, I got 46.67, but on the longer interval, 1 to 10, I got 38.89. Okay, so comparing the two, I would say that the average rate of change I got in part A is greater than the average rate of change I got in part B. So C says use the rate of change from B. So for B, we got 38.89 to predict the distance traveled at hour 7. So this 38.89 is our miles per hour. Okay, we want to travel 7 hours. So I'm going to multiply that by 7. This is our hours. And we would get 272.22. This is our miles. Okay, this is what it's asking for. So we took our miles per hour, so like our speed. Our speed was 38.89 miles per hour. If we drove for 7 hours, we would cover a distance of 272.22 miles. Example 3 says find the average rate of change from hour 0 to hour 5. Then use the rate of change to predict the temperature after 3.1 hours. So notice here we have two separate questions. It's first asking us to find the average rate of change, then using it to find and predict the temperature. So for the first one, we're doing our little T-chart. So we have 0 and 5, and then I'm going to look over here at 0, that's about 200. And at 5, that's 1640. Okay. So using my formula, I do 1640 minus 200 over 5 minus 0. That gives me 1440 over 5, which gives me 288. This is the first part of my problem where it's asking for the average rate of change. Now it wants us to use that average average rate of change to predict the temperature. So we take 288 and we take our hours 3.1 and multiply it to get 892.8. This is the predicted temperature at 3.1 hours. Okay. And then this last part here says, if we wanted to find the instantaneous rate of change at hour 1.5, what would we do to find that rate of change? Okay, so if you look up the definition of instantaneous, it is talking about at one specific point. So it wants us to find the rate of change at one specific point. And that point is that 1.5 hours. So typically when we are finding the rate of change, we're given an interval. But since we're looking at one specific point, we don't have an interval. We don't have that start and finish. So we need to create an interval. So we're going to create an interval. And how we're going to do that is we are going to take very small increments below 1.5 and very small increments above 1.5. Okay, so small increments below 1.5 and above 1.5. So for example, below 1.5, we could do 1.499. Okay, that is a small increment below 1.5. And then above 1.5, we could choose 1.501. That's a small increment above 1.5.